Last time that we were together, I introduced you to the Z-chart and how you can do some amazing problems using your Z-chart. We kept it kind of simple the last time and primarily just worked with introducing you to that and showing you how to do some of those problems. Now, it is going to get to be so much fun today. Before we get there, though, we have to have a misleading statistic before we get going here. Feelings toward government in Washington, federal government. Dissatisfied, 46%. Angry, 45%. Good grief! Does everybody hate the government and what they're doing? Okay? Enthusiastic, satisfied, 9%. It seems like everybody is very frustrated with the government. Hold on. Who is being surveyed? Who is being surveyed? This is the feelings toward the government among Tea Partiers. And if you understand who the Tea Partiers are, they are the very right-wing conservative group of the Republican Party who, by and large, does not like the government. So if you're going to limit, if you're going to remember the bias that we talked about on day one of this course, if you pick your respondents for a survey from a certain group of people, you're going to get biased results, okay? So not a good way to take a survey. All right, here's what we did last time. The steps to go through, hopefully you can read that. Finding a percentage or a probability, sketch the curve, so draw a picture, show the appropriate region, find the z-score, and find the area denoted by the z-score. Let's go through the steps here in a problem like down here. IQs are normally distributed with a mean of 100, standard deviation is 16. So I have 100 here, standard deviation 16. Okay, determine the percentage of people that are between 115 and 140. 115 is over on this side, so here's 115, here's 140. I want to know the area under the curve there. This would also be the same of what's the probability of selecting a person at random and they have an IQ between 115 and 140. Okay, so now all I've got to do, get my trusty Z-chart. Okay, and I want to do your formula here. I want to do 115 minus 100 all over standard deviation of 16, and I want to do 140 minus 100 all over 16. Okay, so let's do it. 115 minus 100 is 15 divided by 16. I get, would help if I turned it on. 15 divided by 16 is 0.94. I'm going to round off. Why? Because when I'm looking up on the chart, it has to be rounded off to the nearest hundred. So make sure you round off correctly. This is 0.9375. The 7 makes it go up to 0.94. And 140 minus 100 is 40 divided by 16. I get 2.50. So I have z values that have these. Here are the z values. Let's look it up. So 0.94, the area from here and down. If I look up 0.94, I get an area of 0.8264. If I go from over here at 140 and down, that's a z of 2.5, and 2.5 is 0.9938. There are my two areas. How do you find the area between? You simply subtract. So I'm going to take 0.9938 minus 0.8264, and I get an area of 0.1674, or 16.74% of all people have IQs between 115 and 140. Okay? Great problem. All right, variably distributed variable. Mean is 10. Standard deviation, 2.57. Find a percentage of all data. We got a whole bunch of questions here. Find a percentage of data between 6 and 8. Between 6 and 8, you would have to do 6 minus 10 over 2.57, 8 minus 10 over 2.57, get your two z values, look them up and subtract, just like we did in the last problem. I'll say it again. We want to go between 6 and 8. 6 minus 10 all over 2.57. Work that out, you'll get your z value for the 6. 8 minus 10 over 2.57, work it out, you'll get your z value for the 10 for the 8. Then you look those up in your chart and subtract the two areas to get the area in between. All right, so let's do this next one. At least 10. What percentage of the data is at least 10? 10 is dead in the middle. That's got to be 50% of the data. At most, 13.5. At most, 13. Over here is 13.5. If it's at most 13.5, it could be anything to the left. So I want to the left of 13.5 would be 13.5 minus 10 all over 2.57 to get my z value. Let's do it. 13.5 minus 10 is 3.5 divided by 2.57. I get 1.36. Remember, round off correctly to the nearest hundredth. To look it up, 1.36, 1.36.9131 is the area, 0.9131. Do I have to subtract from 1? No. I wanted the percentage of the data that is at most 13.5. So this, all of this, 91.31% of the data is at most 13.5. If I wanted what percentage of the data is at least 13.5, I'd want to the right, yeah? Then you'd have to subtract from 1, okay? Find a percentage of all data lying within 1 standard deviation of the mean. 1 standard deviation on either side. Shy-Sam problem, 68.26%. 2 standard deviations of the mean, 95.44% of the data. You don't have to do more. You can work it out like this. I mean, you can put in 1 minus 10 all over 2.57 and negative 1 minus, I mean, you could do that, but you're going to get the same thing. 3 standard deviations of the mean, 99.74%. Empirical rule. Okay? All right. All right, what if you know the area or the probability and wish to find the observation? You do the problem somewhat backwards, okay? So sketch, always draw a picture, find your z-scores. Let's go down here to number 3. A variable is normally distributed, so here we go. Mean is 68, standard deviation is 10. Find the two x values that divide the area into a middle area of 0.9. Middle area of 0.9 or 90%, okay? Now you know, before you even go to work out the problem, 90% is in between 68.26 and 95.44, which is between 1 and 2 standard deviations. So I know my answer should end up being between 1 and 2 someplace, okay? All right, so let's work it out. If this is 90% in here, isn't there 10% left over on either side? Okay, so to find the percentage on one side, you'd cut the 10 in half. So this area right here is 0.05. And why did I choose this one down here, 0.05? Because the chart always gives you the area to the left. Let's do a reverse lookup on 0.05. 0.05 reverse lookup. That's the one that is dead in the middle between negative 1.64 and negative 1.65. We did this last time we were together. It's dead in the middle between negative 1.64 and negative 1.65. which is negative 1.645, right? Dead in the middle, okay? So we know that that's the z-value that has an area of 0.05 below it. Now let's find the data value. Don't we know that this is equal to x minus mu all over sigma, right? And you can solve that equation. Cross multiply 10 times this is negative 16.45 is x minus 68. Add 68 to both sides. So I have 68 plus a negative 16.45. And I get my x value is 51.55. And notice, remember how we said the z values have to be between 1 and 2? Look, negative 1.645 and positive 1.645. So this x value down here, right, is 51.55. How about the x value up here? That's going to be positive 1.645, right? Positive 16.45. So add 68 plus 16.45, and I get 84.45. There are your two values that has 90% of the data in between those two, okay? The variable is normally distributed. Mu equals 70. Draw a picture. Here's 70. Sigma is 12. Find and interpret the quartiles. The quartiles. This takes you back to chapter 3. Quartiles. Quartile Q1 is down here, where you have 25% of the data, 0.25. Q2 is easy. It's 70. Q3 is over here, where you have 25% of the data up there, correct? Okay, so let's find and interpret the quartiles. Okay, so if I know 25% of the data is to the left, here we go again, do a reverse lookup on 0.25, comes out dead even at negative 1.96. So negative 1.96 is the z-value, is equal to x minus mu, 70, all over 12. Cross multiply. Negative 1.96 times 12 equals negative 23.52 equals x minus 70. Add 70 to that to solve for x. I get that Q1 is 46.48. Okay? Now, how can I find Q3 over here? You can do a reverse lookup on 0.75 if you want. If you want, sure, go ahead and do a reverse lookup. I don't care. Or if we know that the z-value down here was negative 1.96, okay, the z-value up here at Q3 has got to be positive 1.96, right? Okay, so positive 1.96 is times 12 equals positive 23.52. Okay, and when you add 70, you get 93 right here, 0.52. Okay, excuse me a second. I thought something didn't look right about that. Sorry. I messed up. I looked up 0.025, not 0.25. 25% of the data is down below. I'm an idiot. Pardon me. Let's do it right. Okay. 0.25. Oh, you dummy. 0.25 is way down at the bottom of your chart, and I think it is a negative 0.67. Negative 0.67 is down here, and up here would be a positive 0.67, x minus 70 over 12. You've got to work out both of those. Oh, yes. Negative 0.67 times 12 equals plus 70 equals, and I get roughly 62 down here. So Q1 is 62. Now on the other side, okay, so I have positive 0.67 times 12. So positive 0.67 times 12 and add 70. And I get 78.04 or roughly 78. And another thing you can do to check this out, you see how 62 is 8 below 70 and Q3 is 8 above 70, okay? All right, so there are the quartiles. 25% of the data would be less than 62, 25% of the data would be between 62 and 70, 25% of the data between 70 and 78, and 25% of the data is bigger. Okay, find two values that divide the curve's area into a middle area of 0.95. All right, let's do that again. So here we go, and I will try to do it correctly. Here is 70, standard deviation is 12. We want to find the two values here that give you 0.95 in the middle. If it's 0.95 in the middle, it is 0.05 left over. So I know that 0.02, there's my 0.025. I was just getting in a hurry. 0.025. If you do a reverse lookup on 0.025, oh yes, it's positive and negative, plus or minus. 1.96 is the X value, minus 70 all over 12. Work out both of those and you'll get your two values. Okay? Great stuff. Okay, study has normal distribution, mean of 1.8, standard deviation of 0.5. Determine the percentage of the data between those two. We've done a couple of problems like that. Determine the percentage of data that exceeds 3. Let's talk about that. So here we have our picture. Mean is 1.8. Standard deviation is 0.5. We want to know the percentage of data that exceeds 3. Here is 3. We want to know that little area there. Okay? Now, you want to find the percentage data here. So if this is 3, exceeding 3, I'm going to do 3 minus 1.8 all over 0.5. So 3 minus 1.8 equals, divided by 0.5 equals, I get 2.4 for a z-value. Look up 2.4. 2.4 is 0.9918. Yeah? But remember, the chart always gives you the area to the left. So the percentage it exceeds 0.9918, you'd have to subtract from 1. Okay? Find the 20th percentile. The 20th percentile, I know that to 1.8 is 50% of the data. So the 20th percentile is going to be down here where this area right here is 0.20. Yes? Okay. So we want to do a reverse lookup on 0.20. And I'm going to the chart. It's either going to be negative 0.84 or negative 0.85. And I think hopefully all would agree with me that it's negative 0.84. Okay, so I have negative 0.84. Negative 0.84 is the z-value is equal to x minus mu all over sigma. Cross multiply, negative 0.42 is x minus 1.8. Add 1.8. So I have negative 0.42 plus 1.8, and I get 1.38. Down here, 1.38 will have 20% of the data below it. If the z-score is positive, the area under the standard curve to the left if the z-score is positive, the area under the standard curve has to be greater than 0.5 because the area from here down is 0.5. So if your z-score is positive, we know the area to the left has got to be greater than 0.5. If the area to the z-value is less than 0.5, it's less than 0.5, I know the z-value is over in here, and the z-value would have to be negative. Yes? Oh, we have a stat race. Okay. We have a stat race. Normally distributed with a mean of 42. Draw a picture. 42. Standard deviation of 4.8. Okay. Determine the percentage of racers that finish with a time greater than 45. So I want up here. Okay. So greater than 45, I'm going to do 45 minus 42 all over 4.8 to get the z-value. That's 3 divided by 4.8. I get 0.63. You have to round off to the nearest hundredth to use your chart. So a positive 0.63. Positive 0.63 should be 73.57%, but hold everything. That's to the left. So I've got to take 1 minus. I've got to take 1 minus 0.7357. Is that what it was? 0.63, 0.7357. Yeah. So 1 minus 0.7357, I get the answer is 26.43%. Okay? We're good? Find the 7th decile. The 7th decile. DEC, decade, 10, right? 7th decile. I know there is some value right here on this side because this would be the 50 percentile in the middle. Decile means 10, so the 7th decile would be 70th percentile. So I know there's something there where this area is 70%. Okay? 70% to the left. I must do a reverse lookup. So I'm going to look up in the body of the graph 0.70. 0.70, 0.70, 0.70. It is either 0.52 or 0.53. Take a second and think about that. Hopefully you'll agree with me that it's 0.52 because that decimal is 15 10,000ths below. And 0.7019 is 19 10,000ths above. So I would want a z-value of 0.52. So I know that 0.52, the z-value, has to be equal to x minus mu all over 4.8. And there we are with another equation to solve. Cross multiply 0.52 times 4.8 equals, and add 42, and I get 44.5. Okay, so at 44.5, and I can round that off a little better, 44.50 would be the 70th decile. 70% of the data is below 44.5. What is z sub 0.2? Remember that notation. Z sub 0.2 is the z-value that has 0.2 to the right. Okay, what is the z-value with 0.2 to the right? You can subtract from 1 and get 0.8 and look it up because the chart always goes to the left. Okay, so looking up 0.8, 0.8, 0.8, 0.8 in the body of the chart, 0.8 should be closest to 0.84, right? 0.84, okay? Or another way to do it is simply look up 0.2. 0.2 is over on the negative side, and 0.2 is closest to negative 0.84. But we know, okay, we know that we want, what is the z-value to have 0.2 to the right, so we know we're on the right-hand side, the positive side, so you have to make the negative 0.84 positive 0.84. And it works perfectly either way. All right, now we come to one of the most interesting problems in this whole section. This is the shoe problems. And let me tell you, you are guaranteed shoe problems on your test. Look at the chart on page 278. On 278, you will see a shoe chart up at the top of the page. It gives the length of the lady's foot, and it also gives the accompanying sizes. All right, so let's draw a picture. Here we have mean is 9.58. Sigma is 0.51, okay? Assuming if your length is between two sizes, you should wear the larger size. Now make sure you understand that. Looking at this chart, okay? Looking at this chart, I suppose my foot is, 8 and 9/16. Suppose the length of my foot is 8 and 9/16. You will not fit into a size 4.5. Do you agree? If your foot is 8 and 9/16, you're going to have to wear a 5. Okay, that's what it means when it says if you're assuming if your length is between two sizes, you have to wear the next biggest one. Determine the percentage of women who wear a size 9.5. Okay, a size 9.5. Find a size 9.5. And size 9.5 is over on the last two columns, or the very last column. If you're going to wear a 9.5, your foot has got to be between 10 and 10 3/16. Comprende? You with me? If you're going to wear a 9.5, your foot has to be between 10 and 10 3/16 in length. So I'm here between 10 and 10 3/16. Okay? You need to do 10 minus 9.58 all over 0.51, 10 3/16 minus 9.58 all over 0.51. Get two z values, subtract them, and you'll get the percentage. When you look up the areas, subtract the two areas, look up your z values, get both z values, look them up, subtract the two areas, you have the percentage. Now, what about a size 6? What about a size 6? 6 is in the second column. Would you agree with me, a size 6, you're going to have to be between 8 and 13/16 and 9? So I'm going to come over here. Here's 8, and here's 8 and 13/16 and 9. Everybody with me? Between 8 and 13/16 and 9 would be the people that wear a size 6. All right, let's work it out. We are going to have to do the same thing as I just mentioned. We're going to have to do 8 and 13/16 minus 9.58 all over 0.51 and 9 minus 9.58 all over 0.51. Let's do the math. Okay, so 13 divided by 16 equals plus 8 equals, so there's 8 and 13/16 minus 9.58 equals, divided by 0.51 equals, I get, round off the nearest hundredth, negative 1.50. 9 minus 9.58 is negative 0.58, divided by 0.51. Negative, round off the nearest hundred, 1.14. Okay, let's look them up. Okay, negative 1.5. Negative 1.5 is 0.0668 from here down. Okay, negative 1.14. Negative 1.14 is 0.1271 from there and down. So subtract those two. 0.1271 minus 0.0668 is 0.06. 6% women should wear a size 6. Okay? If Payless shoe stores are going to purchase 5,000 shoes of a certain style, they must have 6% of those shoes being for women who wear a size 6. What a great problem. 6% of 5,000 is 300 shoes. Okay, they have to order 300 shoes for women because 6% wear a size 6. Ah, don't you just love this stuff? Homework, all book problems and a couple of shoe problems. Okay? As I said, this is the real meat of this course.